on December 19, 2025, the interstellar object known as 3I Atlas will pass at its closest distance to Earth. Space agencies around the world continue to monitor it closely, and new research data suggests that it's one of the strangest and most inexplicable objects ever to visit our solar system. The object was first discovered by astronomers on July 1, 2025, when it was within the orbit of our gas giant Jupiter at a distance of 327 million miles from Earth. Now, moving at an incredible speed of 137,000 miles per hour, it's rapidly approaching our planet. That's nearly twice as fast as most asteroids traveling within the solar system. Some scientists, including Avi Loeb from Harvard University, believe that what's approaching us may not just be a comet or asteroid from another star system, but possibly a spacecraft from an alien civilization. Moreover, Loeb doesn't exclude the possibility that the object may be using some form of disguise to appear as a normal comet, and if that's true, that disguise might already be failing. Recently, 3I Atlas has exhibited strange gravitational behavior that scientists can't yet explain. Its brightness also raises questions. It's far too intense to be caused by reflected sunlight. It almost appears as though the object has its own powerful light source. Not long before that, scientists observed that 3I Atlas was almost unaffected after being hit by a massive solar flare, a burst of plasma and magnetic fields from the sun. It looked as though the object somehow deflected the solar outburst. There's something approaching, and no one can say with complete certainty what it is. Images of the object captured by various space agencies don't reveal its true shape or appearance. Until now, all we've had are photos showing a white dot against the backdrop of space. But recently, on October 3rd, 3I Atlas passed at its closest distance to Mars. On that day, a European Space Agency spacecraft orbiting the Red Planet captured the most detailed image of the object ever taken. What appeared in those images raised even more questions than answers. We're about to address the following questions. Why are scientists at Harvard University increasingly convinced that the object approaching us might be a spacecraft from an extraterrestrial civilization? Can the extremely strange and atypical behavior of this object be explained rationally? How might one of the most mysterious cosmic signals ever recorded from 48 years ago be connected to 3I Atlas? And finally, what unexplainable details were revealed in the images taken from Mars orbit? October the 3rd of this year featured an event long awaited by NASA and European Space Agency specialists. The interstellar visitor that has caused such a stir in the scientific community approached Mars at its closest distance, just 18.6 million miles from its surface. By the time it happened, the Mars Express orbital station that studies the red planet had already been directed toward the coordinates where the interstellar traveler was expected to pass. Scientists hoped to get the first images of it from Mars orbit, but that didn't happen. The object's light turned out to be too dim for the station's optical instruments. Mars Express simply couldn't see it. At the same time, another orbital spacecraft, the ExoMars Trace Gas Orbiter, also attempted to capture images of 3I Atlas. Fortunately for scientists, it succeeded. In a series of obtained images, one can see a bright, slightly blurred spot moving toward the center of the frame, speeding away from Mars at an enormous speed. It's impossible to make out any details since the object was around 18.6 million miles from the orbiter, whose instruments were designed primarily for observing the Martian surface from the height of just a few hundred miles. At first glance, the images look fairly ordinary, but once zoomed in and viewed frame by frame, something strange emerges. It appears as though 3I Atlas changes shape as it moves. Upon closer inspection, bright lights can be seen around a central square-shaped object, almost like they're separate fragments. They appear to move actively around it, flashing and shifting shape. It creates an impression that the object is escorted by other celestial bodies, serving as its protection. All of this seems strange, but according to ESA and NASA specialists, what many interpret as escort or shape-shifting can actually be explained by a combination of several factors. First, the object is far too distant for the weak camera aboard the TGO, causing light from 3I Atlas to bleed in the photos and break into pixels, creating an illusion of motion and fragmentation. Secondly, if the object is indeed a comet, it likely contains volatile materials that can heat up and release jets of gas and dust in different directions, causing flashes and distortions in shape. This effect is further amplified by the camera's movement and the viewing angle, making it seem as though several separate lights surround the object, when in reality it's the same light source. However, ESA and NASA were far from the only ones to capture 3I Atlas near Mars. China also seized the rare opportunity to observe this enigmatic interstellar visitor at unprecedented proximity. To do so, they used the high-resolution HIRIC camera aboard the Tianwen-1 orbiter, which has been orbiting Mars since February 2021. The images show the object surrounded by a huge coma, a cloud of dust and gas measuring between 5,800 and 10,000 miles in diameter, moving through the depths of space. However, the resolution of these images does not surpass that of the photos obtained by ESA and NASA, so it's still impossible to discern the object's details. Even so, the new images have only fueled further debate about what 3I Atlas truly is. Most scientists agree that it's a comet from another star system. Yet, the series of inexplicable and highly improbable events associated with this interstellar object continues to deepen the intrigue. So, is this really just an ordinary comet, or is it something else entirely? As the debate continues, 3I Atlas is beginning to behave in a way that, by all known laws, no comet should. Shortly before the interstellar object approached Mars, a powerful flare erupted on the Sun in late September, a true solar storm that ejected part of its stellar material directly toward 3I Atlas. This stream, made up of plasma and magnetic fields, carried an enormous destructive force. While Earth is protected by its magnetosphere, any comet passing near the Sun has no such defense. That's why scientists were especially eager to see how 3I Atlas would react after colliding with the solar flare. It was clear that if it were truly a comet, the consequences would be immediate and irreversible. The energy impact should have partially destroyed the object, since the body of a comet is mostly made of ice. The powerful magnetic flux, in turn, should almost certainly have altered its trajectory, even slightly. Moreover, after an event like this, a comet typically becomes dimmer, shrinks in size, loses its shape, and sheds 30 to 60% of its mass. Yet, none of that happened. The last thing scientists expected was stability. Yet that's exactly what their instruments recorded. The object's brightness, shape, and trajectory barely changed. Somehow, the interstellar traveler managed to withstand the Sun's energy blast. Researchers believe this anomaly could be explained by an extremely durable core structure, suggesting a highly unusual composition, definitely not ice. According to another, bolder theory, the solar flare didn't actually touch 3I Atlas at all. It's as if the object somehow deflected the stream of solar material and remained completely unaffected. Astrophysicist Avi Loeb from Harvard University stated that a normal comet cannot behave this way. He argues that if it does, then there's a gap in our understanding of such objects. And indeed, soon after this event, scientists observed yet another anomaly around 3I Atlas, even stranger than the last. The image where this anomaly could be observed was captured using the 2-meter twin telescope in the Canary Islands, Spain. The photograph shows 3I Atlas with a small jet, a stream of material forming a typical cometary tail made of ice, dust, and gas. Except this jet is pointed toward the Sun, as opposed to away from it. In other words, it's a kind of anti-tail, a stream of material ejected not away from the star, but directly toward it. This behavior contradicts everything we know about comets. Normally, a gas and dust tail trails behind a comet, since the solar wind strikes the surface and blows particles backward, leaving them behind the moving body. But in the case of 3I Atlas, that wasn't the case. While the object does display the standard bright glow typical of comets, the presence of a second tail aimed in the opposite direction has left the scientific community baffled. The length of this anti-tail is impressive, about 3,700 miles. Researchers have already labeled it one of the most anomalous features of 3I Atlas, with no known parallel among other comets. In turn, Avi Loeb has proposed a daring hypothesis about this phenomenon. He suggests that there's a chance that the anti-tail might not be a natural feature at all, but a technological effect. According to Loeb, what we may be seeing is a spacecraft that uses a mechanism for collecting solar energy, both from light and the solar wind, to power itself. In that case, the observed tail might not be an emission, but rather the result of solar energy being absorbed. Based on researchers' estimates, the object is about 3 miles in diameter. At that size, even with modest efficiency, a technology like this would provide a spacecraft with an enormous supply of energy. However, not long after, new observations showed that the anti-tail gradually shifted direction and turned into a normal tail, trailing behind the object. In other words, the tail took the standard position expected of a typical comet. Yet, according to Avi Loeb, even this normal tail could be artificially generated as part of a disguise meant to imitate a natural comet's behavior. He suggested that if 3I Atlas is indeed an artificial object, it may be using a Trojan horse tactic to conceal its true origin. But this disguise seems to be having serious issues. The anti-tail and the deflected solar flare are far from the only oddities. Spectral observations show that the object has a chemical composition never previously observed in any known comet. The analysis of its emissions point to a substance similar in properties to heat-resistant nickel-iron alloys. Such compounds are extremely rare in nature. They're artificially produced and commonly used in rocket engineering for thermal protection in spacecraft and launch vehicles. Although there's no direct proof yet that 3I Atlas is made of these alloys, many spectral readings point in that direction. Still, due to limited data, scientists are refraining from drawing final conclusions for now. If these findings are confirmed, it would mean that the interstellar object is covered in the same type of alloy we use to protect our own satellites and rockets, and that would be very strange indeed. An increasing number of researchers now consider the possibility that this object could be a piece of technology from another civilization. Among them are James Benford, a physicist and NASA consultant, and Anders Sandberg from Oxford's Future of Humanity Institute. They believe that with so many anomalies observed, ignoring the possibility of artificial origin is simply not an option. The events of October 29th turned out to be especially intriguing. When the interstellar object approached the Sun at its minimum distance, at that moment, it began to behave in a way that was entirely unexpected. The object passed the Sun at a distance of about 126 million miles, roughly 31 million miles farther than Earth's orbit. During this close approach, it was positioned on the far side of the Sun, effectively hidden from Earth, making direct observation impossible. However, 3 spacecraft, SOHO, Stereo A, and GOES-19, were in positions that allowed them to continue tracking the object. What they recorded left scientists puzzled. One of the images, captured by GOES-19, revealed something extraordinary. Spectral analysis showed that the object had changed color. Previously, its dust trail had a reddish hue, typical for comets rich in iron and carbon. Now, it appeared bright blue. This tradition surprised researchers. According to one hypothesis, the unusual coloration could be caused by the release of cyanogen or ammonia molecules from the object's surface. However, there's still no direct confirmation of this, and the observed color change remains under active discussion. Even stranger phenomena began to occur as the object started moving away from the Sun. On November the 3rd, when it finally emerged from behind the star, scientists were able to measure its velocity, and the results defied explanation. To everyone's surprise, the object's speed had indeed increased, but far more than expected. At first glance, that might seem ordinary. Every comet ever observed by astronomers shows some acceleration when passing near the Sun. This happens because the heat causes the surface ice to sublimate, releasing gas and dust, which creates a jet effect that boosts velocity. In addition, the immense gravity of the Sun pulls the object inward, contributing even more acceleration. But in the case of 3I Atlas, the situation was different. From its initial speed of about 130,500 miles per hour, it accelerated to roughly 152,000 miles per hour, significantly higher than predicted. While most scientists attribute this to intense outgassing, Avi Loeb pointed out a serious flaw in that assumption. His calculations suggest that if the acceleration were caused solely by material evaporation, the object should have lost about 13% of its total mass. In other words, by the time it emerged from behind the Sun, it should have been considerably lighter. But no loss of such a significant amount of mass was detected. According to Loeb, this could indicate that the object performed a controlled acceleration maneuver, possibly using nuclear propulsion. Moreover, after its close encounter with the Sun, the object began to exhibit anomalous changes in brightness. Normally, comets brighten as solar radiation heats their icy surfaces, triggering gas release and increased reflectivity. But in the case of 3I Atlas, this process is happening almost twice as fast as with other known comets. Such behavior suggests that processes are taking place on the object's surface that cannot yet be explained within standard physical models. At last, we can observe the object as it moves away from the Sun and becomes visible to astronomers once again. In this image, captured by the Arnaves Observatory, 3I Atlas appears as a bright sphere suspended against the dark background of space. And you might have already noticed something unusual. That's right, the object has no tail. After passing close to the Sun, a comet's tail should have become enormous, stretching hundreds of thousands of miles behind it. But this image shows nothing of the sort. All we can see is the nucleus itself and the surrounding coma. A cloud of gas and dust enveloping the core. Yet, there's no visible trace of a tail. Here is another image, taken in visible light, showing the object as it continued to move away from the Sun. In it, 3I Atlas still appears as a glowing point of light, unchanged since the moment it was first discovered. Meanwhile, Avi Loeb, who continues to gather and analyze all data related to this mysterious object, has reached yet another surprising conclusion. His findings suggest that there is empty space inside 3I Atlas. On October the 11th, 2025, the astrophysicist published his calculations estimating the object's approximate mass. According to his results, 3I Atlas weighs about 33 billion tons, roughly the same as 5,500 Great Pyramids of Giza. However, analyzing its gravitational field revealed a significant anomaly. During 3I Atlas's flyby near Mars, Loeb noticed strange behavior in the object's rotation. A celestial object like an asteroid or comet should have a specific rotation period and react to a planet's gravitational influence by either speeding up or slowing down. But that didn't happen with 3I Atlas. Despite passing close to the red planet, the rotation speed of 3I Atlas remained unchanged. Loeb carefully analyzed the data and determined that the object's rotation period was 16 hours. He then compared this data with its mass and found a fundamental discrepancy. If 3I Atlas were a solid rocky or icy monolith, its mass would have been much higher than the calculated value, or it would have rotated at a different rate. The scientists concluded that there are only two possible explanations. The first is that 3I Atlas contains vast hollow spaces within itself, meaning it has an internal cavity. There's another possibility that the object is made of an extremely low-density material, unlike anything humanity has ever observed. According to Loeb, the first hypothesis seems more plausible and supports the idea of the object's technological origin. After all, if 3I Atlas is indeed a spacecraft, then beneath its massive outer shell, there should be empty space to house instruments, technical modules, equipment, and possibly even a crew. Recent observations of this interstellar object have only deepened the mystery. With every new measurement and calculation, 3I Atlas appears stranger and more anomalous. Loeb's next suggestion takes us back 48 years to an event that might shed light on one of the greatest space mysteries. But before we get to that, let us ask you a question. What do you think a spacecraft from an extraterrestrial civilization might look like? Everyone would probably picture something different in terms of shape and size. But there's one thing nearly every person's imagined spacecraft would have in common: bright lights glowing across its surface. In most science fiction movies, ships are portrayed exactly like that, as complex structures illuminated by lights. Perhaps there's a kernel of truth in that idea. In all images taken by orbital telescopes, 3I Atlas appears unusually bright. Most scientists explain this as sunlight reflecting off its surface, presumably made of ice, a highly reflective material. However, calculations highlight that 3I Atlas is several times brighter than it should be for an object of its size and distance. In other words, to emit such an immense amount of light, it would have to be enormous, tens of miles across, which seems unlikely. Avi Loeb believes the key to the mystery may lie elsewhere. It's possible that 3I Atlas generates its own light, functioning as a small energy source in space. In other words, the object literally glows on its own. The first thing that comes to mind is a spacecraft equipped with a bunch of small light sources, or several powerful ones. Moreover, the glow of the object shows a distinctive pattern, a bright central peak with a steep drop in brightness towards the edges. A distribution like this isn't typical for dusty comets, but could easily point to an artificial, technology-based origin. But Loeb didn't stop there. Recently, he noticed an astonishing connection between 3I Atlas and the most mysterious signal ever detected from deep space. On August 15, 1977, the Big Ear radio telescope at Ohio State University detected a powerful narrowband radio signal. A few days later, while reviewing the data, astronomer Jerry R. Ehrman spotted the spike. The first thing he did was circle it on the printout and write a single word beside it: "Wow." And indeed, that was the only fitting reaction. The signal lasted 72 seconds and had an extremely narrow frequency band, something entirely uncharacteristic of natural radio emissions from stars, galaxies, or pulsars. It was strong, stood out sharply from cosmic background noise, and was never detected again. Humanity has never recorded anything quite like it since. Moreover, the signal came from a specific direction, the constellation Sagittarius. If it had been random noise or diffuse radiation, it would have been spread evenly across the sky, not concentrated in one area. Nearly half a century later, the nature of the signal remains a mystery, but Avi Loeb has a hypothesis. He believes there's a possibility that the "wow" signal was transmitted by 3I Atlas, and he has a rationale to back it up. By tracing and calculating the interstellar object's trajectory, the scientists compared it with the coordinates of the signal's origin. The "wow" signal came from a region only 4 degrees in right ascension and 8 degrees in declination away from the direction of 3I Atlas. The probability of that alignment happening by chance is only about 0.6%. In other words, there's a 99.4% chance it's not a coincidence. According to Loeb's calculations, in 1977, 3I Atlas was about 56 billion miles from Earth. At that distance, light would take roughly 3 days to reach us. From this, the estimated transmitter power needed to produce the signal would have been between 0.5 and 2 gigawatts, comparable to a nuclear reactor. If the signal really was sent by 3I Atlas, that means the object carries a reactor-based energy source, which raises a string of astonishing possibilities. Today, a number of scientists, led by Avi Loeb, consider it highly likely that this object could be a spacecraft. However, most experts still agree that 3I Atlas is a natural celestial body, possibly a comet, though a highly unusual one, or perhaps a fragment of a shattered planetary core, destroyed by a massive cosmic catastrophe. This is the theory favored by many NASA and ESA specialists. When a star explodes as a supernova, it releases enormous energy capable of destroying or breaking apart its planets, sending the fragments drifting into interstellar space. This could explain the object's high speed and unusual behavior. After all, humanity has never before observed a fragment of a planetary core passing through our solar system. But it seems that the long-standing debate over the origin of 3I Atlas may finally be approaching a resolution. A photograph taken by astronomers Frank Niebling and his colleague Michael Buchner on November the 9th at the Pixel Skies Astro Observatory in Spain offers a significant opportunity to shed light on a crucial question. Is this object artificial, or is it a natural celestial body? The image shows the object itself, as well as what many scientists had long been waiting to see in visible light: two distinct jets, an anti-tail pointing toward the sun, stretching about 590,000 miles, and a long tail extending away from the sun, reaching 1,770,000 miles in length. Could this be direct evidence that we're indeed observing a comet? After all, the image exhibits the characteristic features of a comet, yet Avi Loeb cautions against rushing to conclusions, noting that these tails are unusually strange, especially the anti-tail. Loeb's calculations indicate that the anti-tail, nearly 1 million miles long, contains energy far exceeding that of the solar wind. Since it maintains its structure even while pointing toward the sun, its density must be many times greater than that of the solar wind. Based on this, Loeb concluded that for a natural comet to generate such powerful tails, it would need to lose around 50 billion tons of mass per month. This would imply a comet with a diameter of approximately 10 miles or more. According to Loeb, the probability of such a massive interstellar object entering our solar system is less than 1 in 100 million. While Loeb continues to study 3I Atlas and search for evidence supporting his theory of possible artificial origin, most scientists remain convinced that it is indeed a comet, albeit a very unusual one. 3I Atlas is now already leaving the solar system. The November the 9th image has significantly reinforced the hypothesis of its cometary nature. All that remains is to wait for December the 19th, 2025, when 3I Atlas will pass at its closest approach to Earth, and space observatories will be ready for new observations. To make sure you don't miss out this close encounter and the scientific discoveries that will follow, we recommend subscribing to our channel so you can see it first. And if you enjoyed this video, support us with a like, and thank you for watching.